towards towards meeting this on either between 2030, some of the goals, and 2050, and in between those years. And these are the global sustainable development targets during the 2013 and 50 again. It's a basic concepts, and but it has been working towards eliminating the CO2 emission and integrating the sustainable goals. As I said in the previous one, there are like sustainable the seventh goal, but it's still combining the 13th goal as well as the one of a ninth goal. There are trending of EV usages, development of the concept of vehicle to grid, and it is one of newly concept is happening now with the mass scaling and trending of national level of interrelated and transformational and sustainable concepts. And moving on to the study, like my research gap is with the identification of most of the based on the comprehensive literature that I have done, as I have already elaborated in my report, some of the EV, like as I said, E2G, vehicle to grid, those things are being modified. Like when I was referring all the literatures, it shows some kind of a limited to a certain household of one specific task. So the model that I'm going to, like the proposing method is some kind of beyond that, like I'm addressing the national level. So EV usage patterns, energy management system is much more important in my study when I'm stressing this explanation. And also the limitation of EV users' behavior. Like when considering the existing situation, these are the models that have been identified in the previous scholars, and those are like having some kind of limitation with identification of the correct behavior of the EV users, because my model is totally depending on the later part of the final parts of the report should be highly addressing that my report is depending on the EV users' behavior and their how they using their vehicles at what time and how long, what are the miles, like that. So these models has been having the limitation but also having the positives. So combining these, I'm expecting to have a kind of a cumulative or interrelated model in the future times. But still, I'm working with the preliminary stages. Let's transparency of the behavioral thesis, and when we consider the drawbacks, transparency of the behavioral theory, exploring the another research that I'm working on, exploring how the limitation of simulation and optimization models can be overcome. There are certain models which still even though I'm also using this simulation part, there are certain parts still in lacking of elaborating how it should be optimizing the results and the identified overcome of single machine learning models to predict the human behavior. That is, other than the research gap, this is one of kind of a research objective I'm working on. Why I put it here? Because this the second last point is overcoming all the here and avoid statistic assumption during the studies, because in the initial stages of my study as well, I'm using some of the assumption, but I'm trying to overcome them as a later, as kind of a step in the later part by using the actual behavior of the human and substituting it towards the actual model. The aim of the research is very much clear. It is I'm trying to build up a model that is addressing the national level of energy management, which I'm expecting to first substitute to the UK or the national level, and trying to getting towards the other part of the world or the regions. Objectives are clear. like currently this because subject has been already done with the help of the colleagues as well as the group. So already I have been able to develop the mathematical model, but still working on some of the simulation simulatory works. And second one is actually the second part of the first objective, and we are developing on some kind of a model which can be used for generating some data or some kind of a output, and to develop the probabilistic values using the natural behavior. Third one is using some kind of a mass scale data to create the actual behavior of the users. As the final one, as I said, the entire the study's objective is to provide a national level guide or national level proposal to the how to manage how to manage this peak demand during the daytime or like in the national levels. And for the time being, this is a model that I'm working on. This is with the literature support I have presented in the report. This is a Bayesian model, which is a probabilistic theory. Using, as you can see, there are the key is here. The further is also elaborated in the report. This model is the preliminary basic to entire studies. So developing the simulation and developing the next mass scale data interpretation data interpreting model, as well as when proposing to the national level, this is the model that I'm going to use. As this is consist of my studies currently is depending on one model, so that is why I have dedicated one slide and one part for that model. Under the results, still obviously that is apart from the presentation, I have to manage that how I'm going to manage this part. Apart from that, the progress at the year end after 365 days. Already I have conducted a comprehensive literature review, which is contained from smart city concept to what are the existing B2G models that have been used by the previous scholars, as well as which are helping to my perspective. And through the understanding of smart concept and trends towards the study,
neural systems enabling machine to process sensors data more efficient, event-driven manner. This is standard in contrast traditional AI methods, which are often computationally intensive and power hungry. A key innovation in neuromorphic system is dynamic vision sensor or DVS. Unlike conventional cameras that record all pixels at fixed time rates, the dynamic vision sensor excel in performance by meaning of highly sensitive scene dynamics, responding directly to challenge brightness with high temporal resolution. Its bio-inspired design improves intrasense dynamic range, making it ideal for application like high-speed motion detection, object tracking, and shape recognition in real-time environments. DVS data is presented in compact format, timestamp, XY coordinates, and polarity. The timestamp make when the event is occurred, the coordinates, especially where the change happened, and the polarity shows the whether its brightness increase or brightness decrease. For example, the event might look like this. Neuromorphic vision operates on unique principle. Its sensors capture data asynchronously. Each pixel in a dynamic vision sensor functions independently, only recording intensity ranges rather than capturing full frames. This asynchronous approach allows the sensor to cooperate a high temporal resolution, reducing data and power consumption. These properties are incredibly advantageous in high-speed environments such as autonomous driving and robotics, where fast response visual stimulations are essential. When it comes to the data processing, neuromorphic vision system brings major improvements in and performance. Event-based processing techniques such as visual odometry allows to real-time motion environment in estimation in dynamic 3D environments. Researchers have also developed event-based convolutional neural network which use time-agitated data to recognize the object in real time. This method enables enable machine to process information faster with less computational overhead, making them well suited for applications like real-time navigation and object detection. One of the key strengths of neuromorphic vision lies in object tracking and scene understanding. Using event-driven sensors, continuous streams of data allows for precise real-time tracking of fast-moving objects. This is especially useful for scenarios where traditional frame-based cameras struggle, such as tracking high-speed vehicles or objects in dynamic industrial environments. The advantage here is that neuromorphic vision provides more granular and accurate data, enabling better performance in tasks like autonomous vehicle navigation, drones, and robotic systems. Noise modeling and mitigation. Despite its advantages, neuromorphic vision does face challenges. One of the biggest being noise, whether from background activity or thermal effect, can affect the sensor performance. Fortunately, several methods have been developed mitigate this issue. For example, researchers have employed Gaussian mixed models to filter out spurious events. Other approaches include noise-aware learning models, which integrate noise characteristic into event processing pipeline. The other exciting development is the use of semantic communication in neuromorphic vision systems. Rather than transmitting all the raw data, these system focus on sending only essential information. Semantic compression techniques prioritize the most important events, reducing the amount of data being transmitted without losing critical details. This is particularly important in application where bandwidth is limited, such as Internet of Things and edge computing. It ensures the real-time decision can still be made efficiently with minimal data transmission. After I am moving to my motivation, research gaps and objectives of my research. My research is motivated by the growing need for more efficient data processing and communication systems, particularly machine-to-machine and machine-to-human interaction. A traditional method often struggles with.
Okay. You want to tell? Yes.
Okay. So I have separated my objectives and there was three chapters. So in the first chapter, my aim was to investigate what are the vulnerabilities and where can an attacker get access to a semantic system. So the objectives were analyzing potential vulnerabilities, including semantic leakage and misinterpretation of data, and developing and integrate robust security mechanisms and cryptographic techniques to mitigate the identified risks in the encode process, and then simulation and testing. So basically, to develop a secure framework and then do some tests and run simulations on various encoding models to assess resistance to attacks. And also, so my second chapter will be so the aim of the second chapter will be extending these security measures to handle complex data types such as images and videos. For now, I have tested it against the numerical data. So the objectives is like images and videos encryption and exploit and integrate encryption techniques, especially tailored for images and videos, transmission via semantic communications, and ensure the systems can stand adversarial attacks, preventing manipulation or unauthorized reconstruction of sensitive media content, and also the real-time applications. So I hope to investigate the framework's real-time applicability to handle large-scale multimedia data without compromising security. And so the next chapter will be combining efforts to optimize efficiency, develop new security matrix, and validate the system through practical implementations. So the objectives are balancing efficiency and security, developing security evaluation matrix, and practical implementation and testing. So when it comes to the efficiency and security, I will be considering on transmission speed and data security, of course, and the design models that maximize bandwidth usage and in energy efficiency while maintaining the high security. So the second thing is developing security evaluation matrix. So I will be considering on data integrity and adaptive evaluation, like creating adaptive security matrix that dynamically assess the communication system based on contextual importance and meaning protection. And also for practical implementation and testing, I would like to do some performance validations and comparative analysis. So the next slide is literature review. So when it comes to semantic communications, there are a lot of related work regarding this topic, and such as principles of communications, semantic communications, etc. So I have included two diagrams to get a better idea of how semantic communication and paradigm communication differs from each others. So this is traditional communication, and this is semantic communication flowchart. So as you can see in semantic communication, semantic encoders and semantic encoders are used, and then there is a shared knowledge base of both ends. And in traditional communication, it's just the encoder, channel encoder, and channel, and then decoders. So the literature of security of semantic communications. There are some related works. So there are some theoretical frameworks which introduces concepts like semantic improper. They haven't addressed this security challenges and stuff. So the limitations are they don't talk about the semantic security or the scalability or effectiveness and efficiency of those security measures. And okay, so so there is a related work called encrypted semantic communication system. So basically, they have introduced semantic communication systems with encryption and decryption. So this is their this is what they have introduced. So this is the system model. What they are telling is like there are three people here, Alice, Bob, and Eve. So Alice will be sending some information to Bob. So this is based on text type. So Eve is the one who is trying to reach the system and get some data. So here the problem with this system is like they have made some assumptions like they have considered the whole system is like the universal communication system, and all the other users can access the semantic encoder and decoder. So they have assumed like that, and then what they have done is they have input they are inputting a message from this end, and they will be using a key to encrypt it, and then transferred through the semantic encoder, and then the channel encoder, and then through the channel, and decoder, channel decoder, and then the Bob will be using the key to decrypt it, and then decode the semantic decoder will decode the information, and then the output will be there. So they have used symmetric encryption, and they and one of the drawbacks of the system is they haven't talked about how they are going to transfer the key, the keys to Bob. Or so my point is like if, as I like said, they have assumed that all the users of this communication system has access to encoder and decoder. So this is what I have considered when doing my experiments. So the proposal.
Which slide?